Good afternoon, guys. Can you hear me? Guys, can you hear me?
Yes, ma'am, you're audible.
Okay, right. So yesterday we have discussed about the remarks on back propagation. Okay. So yesterday we have discussed the different remarks on back propagation. The next topic is as advanced topics in neural network. Next is advanced topics in neural network. So till now what we have did, we have used one particular linear combination error reducing formula to reduce the error rate, okay, in back propagation. Okay, so beside to this, there are different types of alternative error functions are there. Okay, so if you take in perceptron rule, delta rule, okay, back propagation, it defines error. Okay, so in perceptron rule, by using delta rule, and in back propagation, what has happened, we are getting different types of errors. Okay, so to minimize that, we have used back propagation to reduce the error rate to get the observed target function. We have used back propagation. So this is not possible in perceptron, in single layer neural network. Okay, this is possible in back propagation for reducing the error rate. Yeah. So here, to reduce the error rate more, so what we are doing here, we are using different alternative error functions. Is my voice audible? Guys, is my voice audible?
Yes, ma'am.
Okay, right. Okay. So minimize the error rate. We are using different types of alternative error functions here. The first one is adding a penalty term for weight magnitude. So what is happening here? In this case, we add a term to E. So here you can see one formula, that is E of W arrow. So what is that vector? W vector rate of weights. Okay. I'll show you that formula. So what is the formula which we have used till now? That is E of W vector, that is equivalent to half of sigma D belongs to capital D. Small d is the value which we will be using for instance, single instance in the data set for a one training example of the data set. Capital D is nothing but it is a total data set. So D belongs to D is nothing but one particular training example belongs to the total data set here. Okay. So half of sigma D belongs to D, sigma K belongs to outputs. Okay, and here T K D minus O K D. So this is our actual formula which we have used in back propagation. Okay, so what is the first alternative error function which we are using here? The first one is adding a penalty term for weight magnitude. So here we are using for this formula plus sigma of I comma j w j I square. So this is the extra term which we are using to minimize the error. Okay. So here what we are doing, in this case we are adding a term. So this is the extra term which we are adding to reduce the error. Okay. So what will happen when we add this particular term? It will increase. So that will increase with magnitude of that particular weight vector. Okay. So this the gradient descent to weight with all magnitude. To lesser the error rate, we are using the extra term. This is the alternative term which we are using. This is called as penalty term. This penalty term is used to reduce the error more less. ఇంకా తక్కువ చేయడానికి ఎర్రర్ ఇంకా తక్కువ చేయడానికి ఎక్స్ట్రా టర్మ్ యూజ్ చేసి out. Okay, so this is one more alternative which we are using to reduce the error. Okay, so here E is multiplied by constant upon each iteration. What we are doing, we are particular output of that particular we particular extra term. This will multiplied with constant to minimize the error rate. So this is one particular method. This is one of the alternative method to decrease the error rate. Second one is adding a term. So here you can see adding a term for errors in the slope. or derivative of the target function. In some cases, training information may be available regarding desired derivatives of the target function as well as derived desired values. So here what we are doing, we are adding a term for errors for a particular slope, or we are using one derivative of the target function. So target function derivative use చేస్తున్నాం. Okay, so derivative use చేస్తే with this also the error rate will decrease. So what is our goal? Our goal is to decrease the error rate. మనం ఎర్రర్ రేట్ ని డిక్రీజ్ చేసుకుంటూ వెళ్తున్నాయి కదా మనకి టార్గెట్ ఫంక్షన్ వచ్చేది. సో ఫర్ దట్ పర్పస్ వీఆర్ యూజింగ్ ఆల్ దీస్ డిఫరెంట్ టైప్స్ ఆఫ్ ఆల్టర్నేటివ్ మెథడ్స్. ఓకే, so for that slope I want to give so likewise some data is there. After getting the output, we have plotted in the graph. Okay, so this data, so what is our goal? Our goal is to classify the data. Okay, so linear గా separable చేయడానికి మన aim ఏంటి? linear separable. Okay, so మనం ఏం చేయాలి? డేటాని క్లాసిఫై plotted on the graph. Now what we have to do, we are using some slope here. So this, in this way we are dividing the data, we are classifying the data. So what has happened? Data has been misclassified. So this is one data which has misclassified, this is one data which has been misclassified. Okay, so what will happen to overcome this? We will use one more slope. So likewise, so what has happened, whatever the data which has been misclassified, that will come into this particular group. Okay, so this is nothing but by using slope method. So these are all different types of alternative methods. So here you can see the formula E of W vector equivalent to half of D belongs to D. So this is the formula which we will be using for. Okay, so in the slope we are having some error. To overcome that, we are using this particular alternative function to reduce the error. Likewise, one more is there, that is entropy of the network. So here minimizing the cross entropy. Entropy and error, we are using cross entropy method here. Example enti ante, so you are having some target function. So what you are doing to derive value, okay, some probability of that particular value should be there. Ante enti ante example, guys, can you hear me? Hello?
Yes, ma'am.
Hello?
Yes, ma'am.
Hello.
We can hear you.
Okay, right. So I'm having little bit a internet issue, so that's why I'm asking in middle whether it has been disconnected or continuing. So here the third one is minimizing the cross entropy. So what we are doing here, we are minimizing by cross entropy method. Okay, so this is the third method which we will be using in alternative error function. So if you see here, my target value is this.
Ma'am, screen is not. It is showing a Chrome
Okay.
window.
Right. Sure. Now?
Yes, ma'am. Screen is visible.
Now is it visible?
Yes,
okay, right. So here, this is my target function. Okay. I want to get this. This is my particular target function. I want to get. This is my output. Okay. So after executing, what has happened? I have got one particular output here. Okay. So what I'm doing here, I'm using cross entropy method here. That is nothing but I'm finding the probability. That is nothing but what is the distance between my desired output and my target output. So I'll be finding this with the help of cross entropy method to reduce the error. So this is one type of function which we will be using to reduce the error rate, that is minimizing cross entropy of networks. Okay. So here we are using probability method to minimize the error rate by using log. By using log, we will be decreasing the error rate here. Okay, here D is the probability estimate output. So we want the output by the network for training example D, and TD is the target value, either 1 or 0 for the training example. Okay. So for that, what we are doing here, we are using probability to reduce the cross entropy method to reduce the error rate. So this is one more method. So likewise, there are different types of methods here. One is penalty method, which we will be using. One is slope method. One is cross entropy method. Okay. For the same formula, we are implementing different types of terms to reduce the error rate. Okay. And the another alternative method is altering the effective error function can also be accomplished by weight sharing or tying together weights associated with different units or inputs. So what is one more alternative method? That is nothing but we will be tying. Instead of taking W1 at one time, we will be using the weights W1, W2 at the same time. Okay, so what we are doing here, we are combining two weights at a time and giving to one input value. X1 oka input value, W1, W2 two input weight values okate input ki istunam. So this is tying together weights associated with different units or different inputs. So this is one more alternative method. This next one is, can you hear me? Hello.
yes, ma'am. We can.
Okay, right. And one more is, the idea here is that different network weights are forced to take on identical values. usually to enforce some constraint known in advance to the human designer. So what we are doing here is we are giving the same identical values ని వెయిట్ వాల్యూస్ ని చేంజ్ చేయట్లేదు మనం. అవే ఐడెంటికల్ వాల్యూస్ ని వెయిట్స్ ని డిఫరెంట్ గా చేంజ్ చేస్తున్నాం. ఎగ్జాంపుల్ I'll show you. So this is input layer. This is hidden layer which we are having. Okay. So this is my multi-layer network. Okay. Now what has happened? I have given the input values here, and I have initiated some weight values W111, W121, likewise W211. So likewise I have initiated different weight values also. So what I have used here is to a particular input value I have given different weights. Okay. So these weights, first time I have given W11 as 0.5, 0.12 key 0 each and now. So W1 is equal to 0.5, W1 dash is equal to 0.4, W1 dash is 0. So like I created different value. X21 value, X4. In values can assign. So now as I have some output. So this is my target desired output card. Then you playing weights and change వేరే values ఇవ్వలేదు. ఇవే weight values ని different weight ఇచ్చాను. The same identical values different. Okay. Instead of dash, I have given W3 weight value 1 ఇచ్చాను. Weight value ఉంటాయి identical గా అప్పుడు change. So identical to it's and getting this one alternative. Okay, so these alternatives which we will be using to minimize error. So here we to miss the error. So one decision match we are is insert. So which was approach the distance here. More alternative is minimize the error is insert. Okay, so another method. So till now, what are the different alternate methods we're using? One is penalty method. This one is penalty, adding a penalty term. This is the first one. Second one, adding a term for errors in slope. This is the second one. Third one is minimizing the cross entropy. Fourth one is tying the weights. Fifth one is keeping the initial values for the different weights. Okay, and the next one is optimization method. So optimization method, here we are using line search method. So line search method is nothing but so this is my target. This is my target function. Okay, and I have got predicted one is this. Okay, I'm using line search method. What will happen, which will involve the distance for weight updates. So what I have done, so after updating the weights, I have got some error over here. Okay, so the weights, the error has been decreased. So this is nothing but line search. Okate line lo na error decrease, so that is line search. I mean okasari decrease ayi okasari increase ayi okasari decrease ayi okasari increase ayi, that is not line search method. There I am not using the line search. In a particular way, if the error rate is decreasing in one line, so that is line search method. There I am using line search method. At some places only we will be using these particular methods at different places. Okay, these are not that much means we have got or these are not that much implemented methods. Only we will be using backpropagation algorithm and recurrent neural network. These are the two main networks we will be using. Okay, so other than this also, these are the different methods which we are having here. Okay, so one more method that is conjugate gradient method. So here alternative error minimization method lo we have seen line search. Next is conjugate gradient method. Second method, input method enti ante conjugate gradient method. So what it is? What is conjugate gradient method? So conjugate gradient method is nothing but example enti ante nenu Shamirpet ki ellali. So this is my target function, Shamirpet. Okay, so I have started from here. I've got some output. Okay, this is not correct. I have implemented conjugate gradient method. Now what has happened? The error has been decreased from here to here. I have changed the weights. I have implemented this. Okay, I have got some output here. So here this output is also not correct. Naku target output raaledu ikkada kuda. Okay, so actually after traveling from here, what has happened? I have traveled from here to here. Okay, here to here. After traveling here also, ikkada nunchi kuda Shamirpet inka 10 kilometers e undi. Okay, ee route lo chuste నేను ఇక్కడ నుంచి ఇక్కడికి వచ్చినాక ఇక్కడ నుంచి వెళ్ళి షామీర్పేట్కి కూడా 10 kilometers ఉంది. సో నౌ వాట్ హెస్ హ్యాపెండ్, ఐ హ్యావ్ చూజన్ వన్ మోర్ రూట్. ఓకే, నేను ఇంకో రూట్ చూస్ చేసుకున్నాను. అది సమ్వేర్ ఇక్కడ నుంచి స్టార్ట్ అవుతుంది. సో లైక్ వైజ్ ఇట్ విల్ ఎండ్ హియర్. దిస్ ఇస్ మై టార్గెట్, ఇక్కడ రీచ్ అవ్వాలి. సో ఇక్కడ దాకా వచ్చినాక ఏమైంది, ఇక్కడ నుంచి ఇక్కడికి ట్రావెల్ చేసినాక కూడా నేను 10 kilometers వచ్చాను. నేను ఇంకో రూట్ చూస్ చేసుకున్నాను. అది ఇంకో రూట్ ఏంటి అని అంటే ఇది. ఓకే, సో నేనేం చేశాను, ఎగ్జిక్యూట్ చేశాను, ఇక్కడ నుంచి వెళ్ళి ఇక్కడికి వచ్చాను. వచ్చినాక కూడా నా ట్రావెలింగ్ 10 kilometers. So what has happened? What will happen by implementing the conjugate gradient method? So what has happened is I will be taking the average of these three. So this is nothing but conjugate gradient method. ఇది conjugate gradient method యూజ్ చేసే యావరేజ్ తీసుకుంటే ఏమవుతుంది అని అంటే వెయిట్స్ ని ఇంకా ఎట్లా చేంజ్ చేయాలి, ఎర్రర్ రేట్ ని ఇంకా ఎట్లా చేంజ్ అవుతుంది. So this is one more alternative method, that is conjugate gradient method. So I'm calculating the conjugate of all the different outputs. So this is one more method which we will be using here. Okay, so these are the different alternative methods we will be using to decrease the error rate. So next important topic is recurrent network. So what is recurrent network? Recurrent network అంటే recurrent అంటే ఏంటి అంటే which happens from the beginning. Okay, so that I'll tell you. So this is my network. These are hidden layers, and this is my output. This is hidden layer 1. This is hidden layer 2. Okay, so these are input values. X1, X2, X3. Okay, now these has been assigned to the neurons which are there in the hidden layers. Now I'm getting the output here. Okay, so what has happened after implementing the input values with the help of weight values, I have got some output here. Okay, so this is predicted one. Okay, so my target output is something and my predicted output is something. Okay, network happen from the starting onwards. That is nothing but which happens from the beginning. Okay, so what has happened, whatever the which we have got, that is not, the process is executed from the starting onwards. But in case of back propagation, I'll show you. But in case of propagation, what will happen? So these are the input layers. These are connected to mirrors. Okay, so this is back network. So here input values. This is my layer H1, H2 is output, lab got output. So here we have with some input values with the help of weight values, bias function. I've got here. So the output not cut out. So we'll do is I'll feed forward the weights here and the process will come back properly. So here back propagation be executed in hidden layer. Whatever the fields which are there, that will be updated in hidden layer. That will not start from the input layer. But in case of recurrent, guys, is my voice audible? Can you hear me?
Yes, ma'am, it's audible.
Okay. Is backpropagation. Can you see screen? Screen is visible.
Yes, ma'am, it is visible.
Okay. So in case of backpropagation, we will be backpropagating to n layer. Whatever the weights which are there in the net, those will be changed. So that will not start from starting onwards. But in case of recurrent, it starts from the starting onwards. The process will be done from starting. So this is back here only the weights will change in between hidden layer. Okay. So but in case of recurrent networks, whatever the data or whatever output whatever the net is there will be happening. So it is like neural network. Recurrent network returns back to the input layer. But in case of other networks, it returns back to the hidden layer. So this is the difference between recurrent network and backpropagation. So here in recurrent networks, it will have some memory. Okay. And into output calculations are stored its network memory. So whatever the input calculations which process are stored network memory. That will be storing in network memory. Yeah, guys. Yeah. So the diagram which I'm showing here. So this we will do tomorrow. So there is lot of internet issue today. Okay. So we will stop here. The remaining part within your tomorrow or day after tomorrow. So whenever is the class. So on the day we will finish up this particular topic. So this is very important topic. This we will discuss on Friday. Is it okay?
Okay, ma'am.
Okay, ma'am.
So have you understood the difference between backpropagation and recurrent network? So in recurrent networks, whatever the output which you have got, if the output is not target output, the network will restart from the beginning onwards from the input layer. But in case of backpropagation, it returns back to the hidden layer and update the weight in between them. It will a network. So this is the difference between recurrent network and backpropagation. So the recurrent network we'll see on A. Okay. Who is Arushi? What's your number? Arushi.
Yes, ma'am. Ma'am, 17
What's your
series
number?
563.
Okay, next time log in with your hall ticket number. Okay.
Yes, ma'am.
Right. So anyone, just send me the attendance pic.
Okay, ma'am. I request
Pari,
everybody to stay.
Anybody.
I've taken the screenshot. You all can leave now.
Okay, right.
Ma'am, I've sent it to you.
Okay, right.
Yes, ma'am.